So I'm going to go ahead and look at example 1. And what we're going to do is we're going to find the area of the surface described by y equals x squared over the interval 0 to the square root of 2, which is about 1.4, give or take. And we're going to revolve that about the y-axis. And so I already went ahead and graphed this for you. Notice there's 0, there's the square root of 2. It's about 1.4. Notice that in this case my y value is 2, because think about it. If I plug in the square root of 2 into x squared, I get just plain old 2. So I'm revolving around the y-axis, and so I'm going to end up getting something pretty similar on the other side. Maybe not exactly the same, because I'm not the best artist. But so what we're going to end up having is we're going to have almost like a cup kind of shape, and we're just looking at the outside of it. We're just looking for the area of that cup. And so what I'm going to do both ways. I'm going to integrate it in terms of x's, and I'm also going to integrate it in terms of y, because in this case, let me repeat again, it doesn't matter about the axis of revolution. That's not such a big deal. What matters is how difficult this is going to become as I go about and do the problem. So let me go ahead and do it integrating in terms of x's first, okay? So if I'm going to integrate by x's, what I'm going to do is I'm going to write that function in terms of x and kind of work through my steps again. So let's start. If I write this in terms of x, I'm going to have x squared. So when I take the derivative, we're going to have 2x. Then I need to square that derivative. And I'm going to get 2x squared, which is 4 times x squared. All right? Now I need to add the 1. So we're going to go ahead and just keep following the steps. So 1 plus, I forgot to put the square there. 1 plus f of x derivative squared equals 1 plus 4x squared. Then I also need to go ahead and square root it. So let me go ahead and square root it. Now, notice not such a big deal here. 1 plus 4x squared, not a fraction, not anything to really worry about. So that's one part of it. But the other part that I still need to worry about is this radius. Now, here's the thing. As I'm moving along this radius here, what's happening is, in this case, the radius is just how far along the x-axis I'm going. So actually, my radius in terms of x in this problem is just x. Because again, we're just plugging in x's along this path, okay? So, once I've got this figured out, I'm going to go ahead and write down my interval. So we're going to find the surface area from 0 to the square root of 2 of 2 pi times x times the square root of 1 plus 4x squared. Hopefully you guys are thinking in your heads. I'm going to write my dx at the end. Hopefully you guys are thinking in your heads. Constant, pull it out. So I'm going to have 2 pi from 0 to the square root of 2. I'm going to go ahead and leave my x times the square root of 1 plus 4x squared dx. Hopefully you guys are thinking u substitution in your head. That's a great idea. So u equals 1 plus 4x squared. I am going to go ahead and switch my bounds again like I did before. So I'm going to plug in x is 0 and x is the square root of 2 and see how that changes. If I plug in 0, 4 times 0 squared is still just going to be 0, so that's going to end up being 1 for my u value. Whoop. U equals 1. If I plug in the square root of 2, square root of 2 is squared, so that's going to become 2. 4 times 2 is 9, or excuse me, 4 times 2 is 8, plus 1 does make 9. I was getting a step ahead of myself. So I'm bounding it by 1 and 9 now. I'm going to go ahead and take du, which that's going to be, the 1's going to disappear, that's going to be 8x dx. And so I'm going to move the 8 over because I do have that lovely little x outside. That's a wonderful thing to have. So 1/8 du equals x dx. There's my x, there's my dx. So all I'm going to have to do is switch out 1/8 and make that the square root of u. So let me go ahead and write that over here. So we're going to have 2 pi integrated from 1 to 9 of 1/8 times the square root of u du. Again, go ahead and pull the constant out, take care of that square root of u as write it at u to the 1/2, excuse me. So 2 pi times 1/8 is going to be pi over 4. That's not a very well written pi. Pi over 4. Still integrating from 1 to 9 of u to the 1/2 du. Now, don't forget, u to the 1/2 is going to become u to the 3/2. I'm going to end up multiplying by 2/3 because I'm dividing by 3 over 2. Go ahead and write that as pi over 4 on the outside. Still integrating from 1 to 9. That does actually make things nice and simple when I go ahead and try to plug some things in. I'm going to go ahead and take care of that pi over 4 and 2/3, which is going to end up making pi over 6. And then I'm going to evaluate, so 9 to the 3 halves minus 1 to the 3 halves. Well, that's just going to be 1. 9 to the 3 halves, well, let's see. The square root of 9 is 2. 3 squared, so that's going to be 27. So I'm going to end up having pi over 6 times 27 minus 1, which is going to be 26. So pi over 6 times 26. I can do a little bit of simplifying there. So let's see. If I take out a 2, that's going to be 3 and 13. So my final answer here is going to be 13 pi over 3. Now, I'm going to come back in just a second because this is already kind of a long example, and I'm going to integrate by y's next. But so hopefully, if you guys pay attention, we should end up with a total of 13 pi over 3 as my final answer once again. But I'm going to leave it up to you guys once I get done with this to decide which one you like better for this problem. Again, you can integrate by x's or y's. It really is not going to be a big deal. It's just a little bit different depending on your problem. So again, coming back just a hot second.